Hi, we are now almost into the last session towards the end of the statistics discussions. Herein we take up mode. Previously we had discussed already about mean and median. What is mode? Mode or the modal value, because we will get into group data. In that case it will come into modal value, and then we calculate the total mode in that distribution. Is that value of the variable for which the frequency is maximum. If it is an individual observation, it becomes very easy for us to locate the mode, because that is a more repetitive frequency. Suppose it is this data is given individual observations. This individual observation now needs to be put into a frequency table though. Now that means what? The value of x and then the frequency. First one I write is 110, you then have 120 and then 130, and we also have 140. How many times I have 110? 1, 2. 120 will be 1, 2, 3 and 4. 130 will be this and this, so 2 again, and rest is 140 or again 2. So we see that 120 has got the highest frequency of 4, so this becomes very simple, and the mode becomes 120, against which the frequency is highest. This was simple. When we are given to calculate mode by group, mode in one of the continuous frequency distribution data, therein we again have to locate, as we did in the median, we have to locate the modal class. After locating the modal class, then we apply a formula which I write down here as L plus F minus F1 by, we take up an example that will help us understand this better. How do we reach the modal class, and from the modal class how do we derive these variables? I'm noting down. Okay, here this L I write down. L here stands for lower limit of the modal class. This is all about the modal class. Then there is this H. This H is the width of the class, or the width of modal class. Width of the modal class. Then you have this F1. F, and then I write 1 here like that. F1 is the frequency of the class preceding the modal class. Frequency of the class preceding the modal class. Similarly, F2 will be frequency frequency of the class following the modal class. Okay, and F is, I also missed this F, which is the frequency of the modal class. Now let's take up a question wherein we apply this formula that will help us understand it better. Where do I write it? I write it here. It says, I'm just not writing the statement. It says the expenditure of the household expenditure of manual workers in the city is given, and against which the frequencies are also given for the classes of the expenditure. So I'm writing it as expenditure here, and thereby I'm giving the frequency. I need some more space here. First one is, this is in rupees, so between 1000 and 1500 of expenditure, the frequency is 24. Between 1500 to 2000 or 2000, the frequency is 40. 2000 to 2500, it is 33. 2500 to 3000, it is 28. 3000 to 3500, it is 30. 3500 to 4000, the frequency given is 22. And between 4500 till 5000, frequency given is 7. We have to find the average expenditure which is being done by the maximum number of annual workers. So which frequency is high? That is 40. So the modal class directly has become this 1500 to 2000. We'll note down the variables in the data, in that formula we discussed in the previous page. We discussed L, so it is the lower limit, which is 1500. We had H, that is the class width, it's given to be 500. F is the frequency of the modal class. F1 is the frequency of the class before or preceding the modal class, so that makes it 24. And F2 is one which follows the modal class, so that makes it 33. When we apply it in the formula, I write the formula again for our convenience. So it is 1500 plus 40 minus 24 by, this is not F1, this is 2F. So it is 2 into F, that is 80, minus 24 minus 33 into 500. Now if we calculate, I'm getting 1500 plus, this is 16 by, with this one being calculated, will give us 23 into 500. That's giving us some 1847.862. This I think was not that difficult, except for the fact that you have to remember the formula quite clearly. After the mode calculation, the one which is next is cumulative frequency polygon, or which is otherwise called as ogive. One more thing I forgot here to mention, that the relation between mean, median and mode. Mode is said to be equal to 3 median minus 2 mean. This is a relation between a data given, for the mean, mode, median for a data given. The next, as I was taking up, is cumulative frequency polygon curve, or which is also called an ogive. The ogives are actually drawn by two methods of constructing the frequency polygon. That is, one is called the less than method and the other one is called the more than method. It will not be that comfortable for me to draw on the graph sheet, but we'll be discussing the method how to draw that. The first one I'll be taking up is the less than method. The question reads as, for the data given, draw an ogive by the less than distribution method. We are drawing ogive by less than method. Now the data given is about marks and the number of students. The mark ranges between 0 to 10. The number of students were 7. Between 10 to 20 it was 10. Between 20 to 30 it was 23. Between 30 to 40 there were 51 students. And then it is 40 to 50 there were 6 students, and also they have given the data for 50 to 60, which is 2. Now we have to make this data into a data which only informs on marks less than, as because we are trying to frame the ogive on under less than method. So less than 10, what will be the mark? The less than 10, it will actually be the cumulative frequency. Less than 10, there will be 7 students. Then you have less than 20, it will be then 7 plus 10, that is 17. If the marks are less than 30, it will be 17 plus 23, that is 40. Less than 40 will be 40 plus 51, that is 91. Less than 50 will then be 91 plus 6, that is 97. And less than 60 will be 97 plus 2 or 3. This is 3. Oh, I made a mistake there because I was getting 99. So just check that question again. It is 3. So thereby making this 100. Now what you do is, I cannot draw it accurately quite here, but can just show you. Draw this combinations on the graph. So that means, suppose this is the list. Here you will write the here you will write the marks: less than 10, less than 20, less than 30, less than 40, 50 and 60. On this side you will write the cumulative frequencies. I can take 10, 20, 30, 40, 50, 60 and 70, 80, 90, 100, because your frequency range is still 100, the cumulative frequency. I'm just explaining you the method. You can do by yourself. And then you plot the combination form. Less than 10 marks, this was maybe 7 somewhere here, and then you keep plotting 10, 7, 20, 17, 30, 40, 40, 91, 50, 97 and 60 and 100. Once you do so, after doing so, use your free hand. Suppose I just giving an idea wherein these kind of points may you get, this kind of coordinate points you are getting, because there is a sharp rise here, 91. Then it will be 97 and somewhere be 100. Now use your free hand to join this, plots. This will be your frequency polygon graph or the ogive in the less than method. The same, there is no point, there is nothing much, there is not much difference when you are drawing a more than graph. The only difference is about making the table more than. Herein you are adding the frequencies to get the cumulative frequency for less than. For more than, obviously you will be subtracting that to get the cumulative frequency. In one of the next sessions on statistics, we might just take up any question wherein we have to make or jive with more than method. Thank you.